In this video, I'd like to show you how to solve this integration problem by using partial fractions. Before you use partial fractions, there are two things in general you should try. The first one is to simplify your fraction. That includes to cancel out any common terms. For this question, we have x minus 12 over x times x minus 4. And then you realize this fraction, you couldn't simplify it farther. In this case, you should try method 2, which is some kind of substitution rule. We are not going to the detail of the substitution rule here, but the goal is that we want to introduce a new variable such as u, and let this u equal to a function of f of x. And your du would be f of x, the derivative of f of x, times dx. To be able to use this rule, you have to have f of x dx inside your function so that you can substitute everything in terms of x to in terms of u. A quick example here, if we set our u to be x squared minus 4x, then our du would be 2x minus 4 dx. And you realize this part does not exist in your fraction. Therefore, you couldn't use the substitution rule in this question either. Okay, then now we look at this technique called partial fractions. The goal of the partial fraction is to decompose the fraction you have, which is what's in your question, into a sum of simpler fractions. For example, we know how to calculate the integration of 1 over x minus 2, right? Because that's just equal to the natural log of the absolute value of x minus 2. And if we have something like 1 over x plus 3, and that's going to give us the natural log of absolute value of x plus 3. So we know how to calculate integrals like this. So right now we have something more complicated than that. But our goal is to decompose this fraction into something we can do the integration a bit more easier. For our fraction, we have x minus 12 over x squared minus 4x. And that is equal to, let's factor out the bottom, x minus 12 over x times x minus 4. Then let's break the denominator into simpler fractions, and that gives us something over x plus something over x minus 4. The question remaining here is, we don't know what should be on the top, so let's set it to be a and b. A and b are our unknown in this case. What we want to do is to solve for a and b so that the right side of the equation is equal to the left side. Okay, if we want to add the right side together, what we would do is to times it by its common denominator, which the first term you would have x times x minus 4. On top you would have a times x minus 4. the second term, you would have the same denominator, x times x minus 4. On top, you would have b times x. And we know we want to equal to the left term. So let's write it as x minus 12 over x squared minus 4x. The bottom is already, the left side and the right side are equal to each other. So what we want to worry about is only our numerator. For the numerator, what we have is a times x minus 4 times a plus b times x is equal to x minus 12. In order to let the equation, the left and right side equal to each other, let's combine the terms with x and without x. A plus b times x minus 4a is equal to x minus 12. And what does that tell you? Our a plus b must equal to the coefficient of x, which is equal to 1. And our negative 4a must equal to this constant, which is negative 12. So let's write that out. A plus b is equal to 1. And negative 4a is equal to negative 12. Therefore, we get a is equal to 3 and b is equal to negative 2. X minus 12 over x squared minus 4x dx. We decomposed this fraction into two simpler fractions, which one is 1a over x plus b over x minus 4. And that gives us 3 over x, because b is equal to negative 2 here, so we have minus 2 over x minus 4. Then we can separate those two integrals and calculate them. And that is equal to integral of 3 over x minus integral of 2 over x minus 4. So that becomes a lot simpler to calculate. So we take out the constant. That gives us 3 times the natural log of x minus 2 times the natural log of x minus 4. We also need a plus c here. C is our constant because this is an indefinite integral.